So if we go and see how things are in life, we will notice that there's something with this kind of shape that is a battery. And if every time I'm going to represent one of these, this is triple A, this is double A, it might have different shapes, and it might take me a very long time to draw them. So instead of drawing them like this, I might want to use a simpler symbol. Just two lines. I made this one not that straight, but the idea is that this one is the positive part of the battery, and this is the negative. And we might have in the label here something that says something like this, 1.5 volts, and here we can also note something like that. And even more, we know that the longer bar indicates the positive, so maybe we just put here the voltage. And this representation of battery is what we call, in a schematic circuit, the power source. And in our water analogy, that's a water tank that we put upstream, and we imagine to have a pipe connected to it. So if we have such a thing as a pipe, here we will represent it with a line. And if that pipe gets strangled somewhere, we will note that it has a resistance. And for that, we will put this kind of symbol. There are different ways of drawing a resistor. So this is one of them. It should have 3 spikes on one side, 2 spikes on the other one. And for these kind of things, we are going to note them with V, and these kind of things with an R. But this is going to be with a value noted in ohms. So maybe I put here something like 15 ohms. So if we have these kind of things, that is like a voltage, a power source, and resistance in a resistor here. The battery resistance, we already said that there's going to be a flow of current here. Something, maybe I can even use a color, but the pressure from here, the water, is going to make it go. And we might want to represent that with the letter I of intensity, but it's the same as saying that the current has some volume of electrons, of charges flowing. So you can imagine that I is there, and I is here, or I is here, in the same way that we said in a river, upstream, downstream is the same. So if we start thinking about this, there should be some way to relate this I, this V, that we know that is here, and somehow there should be a relationship between them. And for that is that we have Ohm's law, that it tells us that there's this very simple equation that relates the units. So if I'm writing voltage, I'm going to use a capital V. If I'm writing current, I will use the letter A. I don't know it yet, so I'm going to note it with an I. And the ohm is this symbol. So maybe, and now I can move this term around and swap it in a way that we have something like this. I might need a calculator for some of the equations. I might think that if there is 1 volt, 1 ohm is 1 amp, whatever is the result of this, it's going to be in amps, because this thing will become this. Right? So we have here 1 over 10, and that is the same as saying. There's something else that is peripheral to our course, but it's going to become essential if you're going to read or talk with others. So I will write it down here. So if this is this, what is perfectly correct, is the same as saying that this can also be notated like that.